students, we are going to be looking into reducible homogeneous equations, and the type we are going to look into two important types. So one is dy over dx is equal to a times x positive b times y positive c. The denominator is say a dash x positive b dash y positive some c dash. Now for case 1, if you were to take the ratio, say a divided by a dash, clearly a divided by a dash will not be equal to b divided by b dash. So this is very important, have that in mind. Now for case 2, okay, for case 2, a divided by a dash will be equal to b divided by b dash, probably some constant times. Okay, this is going to be case 2. So in case 2, h value and k value are going to be undefined or indeterminate. Now you will understand what exactly is the meaning of h and k within a few minutes. Now I will be doing questions related to case 1, and then I will follow it up by doing questions related to case 2. So foremost, let us just start off by performing a question related to case 1. So first, let me give you this question. Solve, say dy over dx is equal to y positive x negative 2 divided by y negative x negative 4. Now you can clearly see that from here the value of a is 1, a dash is negative 1, value of b is 1, and b dash is 1. So just find out what is a over a dash. A over a dash is 1 over negative 1, which is clearly not equal to b over b dash. B over b dash is 1 over 1. So this is actually, we are looking at case 1 homogeneous system. So to solve case 1 homogeneous system, what should we do? We need to make the following assignment. We need to take x is equal to capital X positive H, and lowercase y is equal to capital Y positive K. This is the substitution we will have to make. Now when we make this substitution, if I were to take this as 1, I can rewrite 1 to be as, say, take this value, put it here. So we are going to have, no, before I could do that, I need to find what is dx. Now dx is equal to capital dx, and my dy is equal to capital dy. That's also critical. So I can replace dy, which is capital dy, and dx, which is capital dx, to be equal to, in place of y, I'll substitute capital Y positive K. In place of x, I'll substitute capital X positive H followed by negative 2 divided by capital Y positive K negative of capital X followed by negative H negative 4. I can rewrite this as, I'm going to write it like this: X positive Y positive H positive K negative 2 divided by, this is actually negative x, so we can't run away from that negative sign, followed by a y, and I'm going to rewrite this as probably, let me just have it like this: negative h positive k negative 4. So this is what I've got. Now what I wish to do is, I will like to take h positive k negative 2 to be equal to 0, and negative h positive k negative 4 is equal to 0. So if I were to take this as 2, so therefore I can rewrite 2 as x positive y, this is 0, divided by negative x positive y, this is 0, and on the left I got capital dy divided by dx. So now the degree of the numerator is same as the degree of the denominator, so it is homogeneous in nature. So having obtained that, what I'm going to do is, I'm going to say let capital Y be equal to v times x. So this would mean dy over dx is equal to v positive x times dv over dx. Okay, so differentiation. So if I were to take this as 3, so therefore I can rewrite 3 as, in place of dy over dx, I'm going to substitute this, so it's going to be v positive x times dv over dx is equal to x. In place of y, it's going to be vx, negative x. In place of y, is going to be vx. So I can take a x out, that will give me 1 positive v divided by, I can take a x out, I don't have to take negative x out, so let it be positive. So this is going to be negative 1 positive v. So this is what I've got. So clearly the x's gets cancelled, and I'm going to write this as v positive 1 divided by v negative 1. So this is what I've got. And on the left hand side I've got a negative, I should say a positive v. So I'm going to push that positive v to this end. That will become negative. So I've got x times dv over dx is equal to v positive 1 divided by v negative 1 followed by a negative v. That is equal to, taking the LCM as v negative 1, I get v positive 1 negative v squared negative negative positive v. This is what I've got. So this can be rewritten as my negative v squared followed by 2 times v followed by 1 divided by v negative 1. This is what I've got. So now the question remains is, we will have to solve it, and before we could solve it we need to use variable separable, right? So we need to take the dv's together and the x's together. So this is going to be v negative 1 divided by negative v squared positive 2 times v positive 1. This entire thing is times dv is equal to dx divided by x. So this is what I've got. So now the question comes is, we will have to make some substitution. So let's substitute. So I'm going to solve this first. So integrating both sides. So let me make the substitution. So what I'm going to do is, I'm going to say let negative v squared positive 2v positive 1 be equal to some t. This is going to be negative 2v positive 2 times dv is equal to dt. Now if I were to take negative 2 out, this would give me a v negative 1 times dv, right? Negative 2 times v would give me negative 2v, negative 2 times negative 1 would give me positive. So that's fair enough. So this is going to be dt. So I can make the substitution. So this is going to be dt 1 over 2 with a negative sign divided by, this entire thing is going to be my t is equal to integral dx over x. So this is going to be ln of t, okay, of course there's a negative 1 over 2 there, is equal to ln of x positive, I can just place a ln c. Okay, so it depends on you. Since I've got ln everywhere, I can place ln c. Now the question comes is, I will have to get rid of this negative 1 over 2. So to get rid of negative 1 over 2, either you can multiply every quantity by negative 1 over, by 2. So if I were to multiply by negative 2, so I would be getting ln t is equal to negative 2 times ln of x, and this is going to be negative 2 times ln of c, and I can actually I can bring this quantity to this side. So this is going to be ln my t. My t is actually this entire quantity, right? So let me make that resubstitution back again. So this is going to be 1 positive 2v negative v squared, and if I were to bring this to this side, this is going to be positive 2 times ln x, and I've got negative 2 times ln c. That's fine. So now what we will have to do, we can take this 2 onto this end, so that would mean I get a ln x squared positive ln of 1 positive 2 times v. Now let's go back to the substitution. What is the substitution we had? We took y is equal to capital V times x, so from here v is equal to capital Y over x. So I need to place it that place these values back. So it's going to be 1 positive 2 times capital Y over x negative y squared over x squared is equal to, now I can actually take this as c squared, right? It's negative times c squared, that's going to be 1 over c. Probably you can either use it as some constant, so you can place some constant k. It's not going to matter, so you can do that. Now what I wish to do is I will have to club these two quantities together, and now before I could use this as some k, let me just retain, because I need to get rid of this logarithm. So let me just retain ln, this is going to be c negative 2, because this 2 goes over here, it's going to be c negative 2. So let me just retain it as it is. So now the time comes to clubbing these two together, so I would have to use some space. So what I will do, I will use the space here. So ln, we know that ln of a positive ln of b is equal to ln of a times b. So I would like to club these two things together. So that would give me so that's going to be ln of x squared times 1 positive 2 times y over x negative y squared over x squared is equal to ln of c negative 2. Now clearly you can see that this quantity can be pushed inside because of the distributive property. So I'm going to take this inside, x squared inside, that will become x squared positive 2 times x will get cancelled, giving me xy, and then followed by y squared. So this looks really neat. And of course on this side it's going to be ln of c raised to the power of negative 2. Now I can drop log both sides, so that would mean I get x squared positive 2 times xy negative y squared is equal to c raised to the power of negative 2, or that's fine, it's not going to impact us in any way. Now the much important point is we will have to make the substitution. So what is the substitution we started with? We started with the substitution that x is equal to capital X positive h and y is equal to capital Y positive k. This is a substitution we add, but the much important point is that we will have to, clearly you can see here, we add h positive k negative 2 is equal to 0, negative h positive k negative 4 is equal to 0. So from here I can clearly find out by cancelling h with negative h, I can get 2 times k, I'm just adding it, is followed by negative 6 is equal to 0. So from here 2 times k is equal to 6, so from here k is equal to 3. Now if k is equal to 3, I can just take it and substitute it here. So if I were to do that, I'm just going to substitute k is equal to 3 here. So that means h positive 3 negative 2 is equal to 0. So that means h is equal to negative 1. So clearly you see everything is working out. H is equal to negative 1 and my k is equal to 3. I'm just going to substitute it here. So if I were to say x is equal to capital H negative 1 and capital X has to be substituted. So capital X is equal to x positive 1, that is one substitution, and my k is equal to 3. So that's going to be y is equal to capital Y positive 3. So that means capital Y is equal to y negative 3. So everything is working out perfectly. So all I need to do is take the values of capital Y, substitute here, take the value of capital X and make the substitution here. So let me do that. So this is going to be, if I were to substitute it, so let me just take this as sum 4. So therefore I can say 4 can be rewritten. I'm going to use the space here. So that's going to be x positive 1 raised to the power of 2 positive 2 times x positive 1 times my y is y negative 3 negative y negative 3 raised to the power of 2 is equal to some constant k. I can just put that as some constant k. So this is what we have got, and the perfect answer to the solution. So this is the exact answer to the solution for that particular question. If you want, you can distribute it and place the final answer, but I think this is the exact right spot to stop. So thank you, students. We can see another example. Welcome, students. In this class the topic is reducible homogeneous equation. So this is probably the next varieties of homogeneous equations that we will have to focus on. It is very critical that we understand this. Now the general form is dy over dx is equal to ax positive by positive c divided by px positive qy positive r. Now you can clearly see the numerator is a linear equation and the denominator is also a linear equation. Now if you were to see the degree of x, it is 1, the degree of y is 1, but the degree of constant, this is a constant present here and its degree is 0. So clearly it isn't a homogeneous equation. And if you were to compare the numerator with the denominator, you can see the same picture. The degree is 1 here for x, the degree is 1 here for y, but r is a constant, its degree is 0. But we are talking about the degree of the numerator being equal to the degree of the denominator for homogeneous equations, which totally fails here. So having got that, what we are going to do is we are going to be making sure that we can adopt the concept of some level of manipulation in converting the linear type into a homogeneous equation type. So that is our objective. So having got that, so let me just place this in a box. So this is the pattern that we will be looking forward. So now we are given a question. Say solve, say the question is dy over dx is equal to x positive 2y negative 3 divided by 2x positive y negative 3. Now if you would remember, in variable separable we took the coefficient that is present here, added with the coefficient that was present here. So we were looking for b1 added with a2, and if we got it to be equal to 0, then we multiplied the quantities and then we simply integrated and we got the result. So when we're talking about b1, I'm talking about the coefficient of y here. When I'm talking about a2, I'm talking about the coefficient of x here. So the coefficient of y added with the coefficient of x, if it produces 0, then we wouldn't have the requirement to handle or requirement to do the process which I'm going to show you now. That is not really required. You can directly integrate it by cross multiplication. I'm going to show you an illustration for that. But in the meantime, clearly we can see that the coefficient of y added with the coefficient of x is not equal to 0. So that is the reason we are trying to convert this system into a homogeneous equation. So for that, the first thing that we will have to do is we will have to take a substitution that x is equal to capital X positive h. So we are going to do that, and then let me write that. Let x be equal to capital X plus h and y be equal to capital Y positive k. Now capital X, capital Y, they are variables, but h and k are constants. So maybe you can write that h and k are constants. So having set this, we will have to rewrite the given system. So foremost I will differentiate this. So differential of x would give me dx. Differentiation of capital X is going to be capital dx. So this is going to be dy. This is going to give me capital dy. So let me rewrite equation 2 or system 2. So 2 can be rewritten as, in place of dy, I'm going to say capital dy divided by, in place of dx is going to be capital dx, is equal to, in place of x is going to be capital X positive h positive 2 times capital Y positive k negative 3 divided by 2 times of capital X positive h positive capital Y positive k negative 3. I'm going to rewrite this. So this can be rewritten as x 2 times y, and then I've got a h and a 2k and a 3, and this has to be followed by 2 times x positive y positive, I have a 2 times h and a k and a 3. So what I'm going to do is, I'm going to take, let h positive 2k negative 3 be equal to 0 and 2 times h positive k negative 3 is equal to 0. So if I were to take this as 3, so therefore I can rewrite 3 as x positive 2 times h. This entire thing is going to be 0, so probably you can place that 0 divided by 2 times x positive y positive, this entire thing is 0. On the left you got capital dy and capital dx. So this is actually x positive, in fact 2 times y, this should be 2 times y, it's not h there, it's 2 times y, and this is equal to 2 times x positive y. So this is clearly homogeneous, which is homogeneous in nature. Okay, now because it is homogeneous in nature, what I can do is let y be equal to capital V times x. So differentiating this, I get dy over capital dx is equal to v positive x times dv over dx. So if I were to take this as 4, I can rewrite 4 to be as, in place of dy over dx it's going to be v positive capital X dv over dx is equal to x positive y is vx divided by 2 times x positive v times x. I take a x out, I get 1 positive 2 times v divided by, I take a x out, I get 2 positive v. Now clearly the x and x can be cancelled, so this is equal to 1 positive 2 times v divided by 2 positive v. I can move this v to the other side, so this is going to give me x times dv over dx. Now if I were to take the LCM, I get 1 positive 2v negative v times 2 positive v over 2 positive v, which is equal to 1 positive 2 times v negative 2v negative v squared divided by 2 positive v. Now clearly positive 2v negative 2v can be cancelled, so that's going to give me 1 negative v squared divided by 2 positive v. On the left I get x times dv over dx. Now we can always use variable separable, so I'm going to do that here. So this is going to be dv over 1 negative v squared, and I can push this, so it's going to be 2 positive v is equal to dx over x. So I can integrate both sides. So if I were to integrate both sides, now I can make some substitutions for this. So what I would do is I would like to rewrite this quantity as 1 positive v positive 1 times dv divided by 1 negative v squared is equal to integral dx over x. Now this can be rewritten as integral 1 over 1 negative v squared. That's fine, probably that's the best way to write it. So followed by, I have to take in 1 positive v divided by 1 negative v squared. Okay, like that. dv is equal to integral dx over x. So that's fair enough. So we got that. So now what we will do is we will have to use this formula. So what is the formula I'm going to use? We know that I've already mentioned this formula. We know that integral dx divided by x squared. In this case it's a squared negative x squared. So a squared negative x squared is equal to 1 over 2 times a ln of modulus of is going to be a positive x divided by a negative x. So this is the formula plus constancy that we would be using. So if I were to use this, this can be rewritten as 1 over my a is 1 times ln of 1 positive v divided by 1 negative v. Okay, now I got this 1 positive v times dv divided by 1 negative v squared. So let me write that down, 1 positive v. Now this one 1 negative v squared, I can rewrite 1 negative v squared as 1 squared negative v squared, which is nothing but 1 negative v times 1 positive v, right? So if I were to do that, this is going to be 1 negative v times 1 positive v times dv. So in fact I should place implies because this is all left hand side. So this is equal to integral dx. So let me just retain it like that just for time being. Now I can clearly cancel 1 positive v, 1 positive v, and then this would imply I get 1 over 2 ln of 1 positive v divided by 1 negative v positive integral of dv over 1 negative v. Now integral of dv over 1 negative v, we can make some substitution using log. So what I'm going to do is I'm going to say let 1 negative v be equal to say some t. So negative dv is equal to dt. So this is going to be negative dt over t, which is nothing but negative ln t, which is nothing but ln of t is 1 negative v. Of course I got a negative sign, probably I'll just place a negative sign here. So what I would do is I will just substitute in place of this, I will substitute this. So this is going to be negative times ln of 1 negative v is equal to ln of x positive c. So this is what I've got. So now I can actually rewrite this with this negative sign being removed. In fact, by distributive property we can get rid of that. So this is going to be 1 over 2 times ln of 1 positive v divided by 1 negative v negative ln of 1 negative v is equal to ln of x positive c. In fact, I don't have to place this modulus sign, I can just place a parenthesis. Now if I were to multiply by 2 throughout, so this is going to give me ln of 1 positive v divided by 1 negative v, and then this is going to be 2 times of ln of 1 negative v. I'm multiplying by 2, so it's going to be 2 times ln of x positive 2 times of c. Now I can make the substitution. What is the substitution? We know that capital Y is equal to v times x, so my capital V is equal to y over x. So I will have to take this value and substitute it here. So if I were to do this, I would get ln of 1 positive capital Y over x divided by 1 negative capital Y over x negative 2 times ln of 1 negative capital Y over x is equal to 2 times ln x positive 2 times c. So we will have to do some simplification. So for that I will have to move over to the next page. So we can perform the simplification. So this is going to be ln of x positive y divided by x, and this is going to be x negative y divided by x, right? Negative 2 times ln of x negative y divided by x is equal to 2 times ln of x positive. You can either write it as 2 times c, or you can write it as ln c, 2 times ln c, because you have logarithmic being present everywhere, so that doesn't matter because it's still going to be an arbitrary constant. So you got these two terms. Now what we can do is we can actually rewrite this. Now in this case the x and x can be cancelled here, right? So that would mean I get ln of x positive y divided by x negative y negative 2 times. I can rewrite this as ln of x negative y negative ln of x, right? So this is what I've got. On the right hand side it's going to be 2 times ln x positive 2 times ln c. I can rewrite this as ln of x positive y divided by x negative y minus 2 times ln of x negative y positive 2 times ln of x is equal to 2 times ln of x positive 2 times ln of c. Now these two things can be cancelled. Now I can rewrite this as ln of x positive y divided by x negative y. I can push this 2 to the other end, so it's going to be ln of x negative y raised to the power of 2 is equal to 2 times ln c. Now I've got ln a minus ln b, which can be written as ln of a over b. So if I were to rewrite this, this is going to be ln of a x positive y divided by x negative y divided by my b. My b is x negative y raised to the power of 2, right? So this is actually spreading all through this region. So this is equal to 2 times ln of c. Now if I'm going to simplify this, so this is actually over 1. So if I were to rewrite this, I can rewrite this as ln of x positive y divided by x minus y raised to the power, this is 2 and this is 1, so this is going to be 3. So this is going to be ln 2 times ln c. I can write it as c squared. Now we got ln on the left, ln on the right, so removing ln both sides we get, so you get x positive y divided by x negative y raised to the power of 3 is equal to c squared. Now from here you get x positive y is equal to c squared times x negative y raised to the power of 3. Okay, now we have almost reached a solution, but if you were to notice, all of these are all capital X capital Y. and we have executed the entire solution using capital X and capital Y. So now it's time for us to resubstitute the values that we took, because we started with let X be equal to capital X positive H and Y be equal to capital Y positive K, and we also took H positive 2K negative 3 equal to 0, if you would remember, and followed by 2H positive K negative 3 is equal to 0. Now I can make the substitution back here, but the only thing that prevents me is the value of H and value of K. So we need to obtain the value of H and value of K. Now if you remember, I have taken H positive 2K negative 3 is equal to 0 and 2H positive K negative 3 is equal to 0. So what I'm going to do is I'm going to multiply this by 2. So this is going to be 2 times H, and this is going to be 4, and this is going to be 6. So now I'm going to add them both. In fact, I'm going to subtract. So that means I have to change the sign. Plus is the minus, minus is the plus. So if I were to do this, 2H and 2H, they get cancelled. I get 4K, negative K, that means 3K. Now negative 6K and positive 3K, that's going to give me negative 6 added with positive 3 would give me negative 3 is equal to 0. So 3K is equal to 3, therefore my value of K is 1. So I've got the value of K. Now to get the value of H, all you need to do is to substitute it here. So just go and substitute the value of K over here, because I have not changed this system at all. So this is going to be 2 times H plus 1 negative 3 is equal to 0. This is going to be 2 times H minus 2 is equal to 0. So 2 times H is equal to 2, so H is equal to 1. So I've got the value of H and K. So from here, if I were to substitute, X is equal to capital X positive 1. So that means X minus 1 will be my capital X, and over here I get Y is equal to capital Y plus 1. So capital Y is going to be Y negative 1. So this is the substitution we will have to make here. So all these things are for your understanding. You don't have to show them. All you need to do is to just ensure that you have achieved the value of H and K, and then re-engineer to get the capital value, or in other words to get the value for capital X and capital Y. So if I were to take this as sum 5, so I can state here, therefore I can rewrite phi to be as, in place of capital X, I'm going to say X negative 1 positive capital Y, Y negative 1 is equal to say sum C squared and X minus H. So capital X, that's going to be X minus 1 negative capital Y, Y negative 1, and that has to be raised to the power of 3. So I can rewrite this as X positive Y negative 2 is equal to C squared. I can substitute some K, and this one is going to be X negative 1 negative Y, and negative 1 with positive 1, it will get vanished, right? Because this is negative 1 and this is going to be positive 1, so this is going to be raised to the power of 3. So you've got a system in this fashion, and if you want, you can push this 2 to the other side and write this as X positive Y is equal to some K times X negative Y raised to the power of 3, say some positive 2. Either this, or you can stop here. Depends on your requirement. So that completes the solution to this question, students. Yes, I understand this is a bit lengthy, but it doesn't mean that you can skip this, because knowledge is power. So students, we are given this question. Foremost, let us find out what is dy over dx. So I will move this to the other end. So that would mean 4 times x positive 8y positive 5 of dy, and on this end it's going to be 3 times y positive 2 times x positive 4. This is dx. So dy over dx is going to give me, this is going to give me 3 times just one issue here. This is actually not 8. This is just for the sake of this illustration, we will have to take this as 6 so that I can demonstrate to you the case. So having obtained that, so we will have 3 times y positive 2x positive 4 divided by 4 times x positive 6y positive 5. So this is what we have got. Now I can rewrite this as 2x positive 3y positive 4 divided by, now the denominator is going to be 2 times of 2x positive 3y positive 5. Okay, that's fine. Now just compare this to our a over a dash and just get the value of a over a dash. Now my a is 2 and my a dash is 4, so I'm getting 1 over 2 for this. Okay, that's fine. Now connect, or I should say compare it with b over b dash. My b is 3 and my b dash is 6, so what do I get? I get 1 over 2. So clearly you can see that a over a dash is equal to b over b dash. So that means h and k are undetermined or indetermined or undefined. Okay, so we will not be able to use the same principle which we have seen in case 1. That is the reason I have taken the value of y to be as 6 so that I can demonstrate to you how exactly this works. Now we will be using this, so I would be taking dy over dx to be equal to 2 times x positive 3y positive 4 divided by 2 times of 2x positive 3y positive 5. So this is the required equation or system, I would say, that we would take. Now what I would do is I will take, let 2x positive 3y be equal to some v. I differentiate this, I get 2 positive 3 times dy over dx is equal to dv over dx. So from here, what do we get from here? So 3 times dy over dx is equal to dv over dx. I can move the 2, so I get negative 2 there, and it can be further rewritten. Dy over dx is equal to 1 over 3 times dv over dx negative 2. So why do I do all these things? I did all this so that I can actually substitute in place of dy over dx. I can make this substitution. So let me just take this as 2. So therefore I can rewrite 2 as, so in place of dy over dx I'm going to substitute 1 over 3 of dv over dx negative 2, and that is equal to 2 times of x positive 2y. 2 times of x positive 2y is going to be my v. So let me place that v followed by a 4 and 2 of 2x positive 3y. That's going to be my v again. So it's going to be 2v positive 5. Now what I can do is I can cross multiply. If I do that, I get 3v positive 12 divided by 2v positive 5. I got a negative 2, so I push it, I get positive 2. So now I take the LCM as 2v positive 5. That would give me 3v positive 12 positive 4v positive 10. I can rewrite that by adding this and that, 7v, by adding this with this, that's 22 divided by 2v positive 5. On the left I get dv over dx. Now it's all lowercase, so I need to cross multiply. So that would mean I get 2v positive 5 divided by, when I say cross multiply, I'm actually connecting this with this. Okay, I hope you're following it. So 2v positive 5 divided by 7v positive 22 times dv is equal to, so I just got a dx there, that's it, I have a dx. So now I need to integrate these two quantities. Now you can clearly see the degree of the numerator and the denominator are same. So that would mean I will have to divide 2v positive 5 by 7v positive 22. Now I need to get a 2v there, so the only possibility is multiplied by 2 over 7. So when I do that, that gives me 2v followed by 2 over 7 multiplied by 22. That's going to be 44 over 7. So I need to subtract, so that gives me 5 negative 44 over 7. So if I were to simplify, it's going to be 35 negative 44 over 7. So that has to be subtracted, and that would give us, so this is going to give me negative 9 over 7. So the quotient is 2 over 7. Place that 2 over 7 followed by negative 9 over 7 divided by the denominator 7v positive 22. This has to be integrated, right? So this can be rewritten as 2 over 7 times dv negative 9 over 7 times dv over 7v positive 22 is equal to integral dx. So upon integration I would get 2 over 7 times v negative 9 over 7 times the ln of 7v positive 22. Quotient of v is 7, so it's going to be 7 squared is equal to, when I integrate dx, I get x positive c. Now I can get rid of the 7 squared, so that means I will be multiplying by 7 squared throughout, and that would give me a 7 here, so it's going to be 14v followed by negative 9 times ln of 7v positive 22 is equal to 49x positive 49c. But my v is 2x positive 3y, right? So substitute it here. So if I were to take it as 3, so therefore 3 can be rewritten as, so it's going to be 14 of 2x positive 3y negative 9 times ln of 7 times of 2x positive 3y positive 22. Of course the right hand side stays as it is. Now you can either bring these things down or simplify them, depends on your requirement. So what I would do is I would just retain it as it is, 14 times of 2x positive 3y negative 9 times, at least in this case 7 times 2 is 14x, and this is going to be 21y and positive 22. So that's the best we can think about it now. So this is a good place to stop, students, and this is a beautiful solution. If you want, you can always get rid of the parenthesis and then club 49x with this quantity, but that wouldn't be necessary for now, and this is a good place for us to stop. Students, we're given the question, solve dy over dx is equal to x positive y positive 3 divided by 2x positive 2y positive 1. This is a linear form in the numerator and a linear form in the denominator, and hence I would be attempting to reduce this into a homogeneous equation. So foremost what I will do is I will just take, let capital X be equal to let small x be equal to capital X positive h, and then y is equal to capital Y positive k, where h and k are constants. So if I were to differentiate, this is going to give me dx is equal to capital Dx and dy is equal to capital Dy. So I'm going to take this as 1, and I'm going to rewrite 1 as, in place of dy it's going to be capital Dy, in place of dx it's going to be capital Dx, in place of x it's going to be capital X positive h, in place of y it's capital Y positive k positive 3, divided by 2 times of capital X positive H positive 2 times of capital Y positive K positive 1. I can rewrite this as capital X positive capital Y positive H positive K positive 3 divided by 2 times of X positive 2 times of Y positive 2 times H positive 2 times K positive 1. Now what I'm going to do is I'm going to take let H positive K positive 3 is equal to 0 and 2H positive 2K positive 1 is equal to 0. Now you can solve it and find the value of H and K. Probably I will just do that. So I will multiply this by 2. So this is going to give me 2H positive 2 times K positive 6. This is 2H positive 2K positive 1 is equal to 0. Now if I were to subtract 6 negative 1, that's 5 is equal to 0. So which is basically contradiction to our number theory concepts. So what is the understanding here? The understanding here is that we cannot adopt this technique to solve this question. So what is the technique that we need to adopt? So I'm going to show you the technique here. So we got dy over dx to be equal to x positive y positive 3 divided by 2 times x positive 2y positive 1. Now I can rewrite the denominator as 2 times of x positive y positive 1 and the numerator stays as it is. Now instead of making this substitution, small x is equal to capital X positive H and small y is equal to capital Y positive K, I'm going to say let x positive y be equal to v. Right? So if I differentiate, I get 1 positive dy over dx. Dx is equal to dv over dx. So therefore dy over dx is dv over dx negative 1. So this is the substitution which we will use. So if I were to take this as 2, right, therefore I can rewrite 2 as, in place of dy over dx, I'm going to use dv over dx negative 1 is equal to, in place of x positive y, is going to be v positive 3 divided by 2 times of v positive 1. Now I can move this negative 1, so that would give me dv over dx is equal to v positive 3 divided by 2 times of v positive 1 positive 1. I can take the LCM as 2 times v positive 1 and that would give me v positive 3 positive 2 times v positive 1, which can be added giving me 3v positive 4 over 2v positive 1. So now we have got dv over dx to be equal to 3v positive 4 divided by 2v positive 1. So now I would like to use variable separable. So that would mean I got 2v positive 1 divided by 3v positive 4 on one side times dv is equal to dx on the other hand. Now the degree of the numerator and the denominator are one and the same, so we will have to do some manipulation in this case. So the manipulation is divide 2v positive 1 by 3v positive 4. Now clearly I need to get a 2v. So how do I get it? Clearly if I were to multiply 3v by 2 divided by 3, that would cure my requirements, right? So this would give me this, followed by a positive 8 over 2 over 3 multiplied with 4 will give me 8 over 3. So now if I were to subtract, I will have to subtract 1 followed by a negative sign and 8 over 3. That's going to give me negative 5 over 3. So all these things are all working working column for your understanding. So you don't have to do these things, but just for your understanding. So this is actually the quotient is 2 over 3 followed by 5 over 3 the remainder and divided by 3v positive 4. This is with dv and this is with dx. Now what I can do is I can rewrite this as 2 over 3 times dv followed by a negative 5 over 3 times dv divided by 3v positive 4 is equal to dx. Now I would like to integrate. So this is integration. So this is going to give me 2 over 3 times v. This is going to give me 5 over 3. This is going to be ln of 3v positive 4. And I need to divide by this coefficient, which is going to be 3. And this is going to be x positive constant c. So I can rewrite this as 2v over 3 negative 5 over 9 ln of 3v positive 4 is equal to x positive c. But what is my v? But my v is x positive y. So I will have to substitute it here. Probably I will use this space here. So that would mean I have 2 times of 2 over 3 of x positive y negative 5 over 9 of ln of x positive y. So it's going to be 3x positive 3y, 3x positive 3y positive 4 is equal to x positive c. I think this is the right place to stop for the solution. Maybe if you want you can simplify it, because there's an x here, you can simplify this, but I think this is fine. Thank you students, enjoy your day and make sure to practice these questions. The most important point is that practice makes perfect. In fact, they say that without practice it isn't easy to get hold of these questions, for the fact that these questions require multiple stages of operation. So having mentioned that, students, we are producing new content every day on all areas of mathematics. We are also producing content on competitive mathematics, Math Olympiad, and mathematics for various entrance examinations. If all these things are of interest to you and you are excited, and if you would like to receive our content, please subscribe and come on board. Thank you students, and I wish you all good night.